Euclid Book 3, proposition number 4 is one of those really super silly proofs, okay? What Euclid does, he first has you draw a circle. This is the circle right here, and we have two lines, which is AC here and BD here. And they're drawn from one part of the circumference of the circle to the other part of the circumference of the circle, okay? Now, these two lines here do not go through the center of the circle, which is F, right over here. And since they do not go through F, then they are not diameters, okay? The only way you'd have a diameter is if it passed through the center of the circle. Alright, so Euclid says, okay, let's suppose you draw two lines here, like you have done here, on a circle. Well, if you do this, and neither one of these two lines pass through the center, then they do not bisect each other. AC is not bisected by BD. He says, well, let's just try to prove this. Well, first of all, Euclid says, I want you to find the center of this circle here. And he says you're going to use Book 3, proposition number 1 to find the center, which happens to be F. And he says, then I want you to draw a line from point F to point E. Okay. Once you've drawn that line, then you're going to hypothetically suppose that the length of line AE, which is this is A and this is E right here, this length right here, is equal to EC. Now, obviously, you see at this point they're not equal, but we're going to hypothetically suppose that they are. And we're going to hypothetically suppose that BE and ED are the same length. And as you can plainly see, they are not, but we're going to hypothetically suppose that this length and this length are equal. Now, we're also going to say that by Euclid Book 3, proposition number 3, which clearly stated that a straight line like this that doesn't go through the center is bisected by a line that does, then that line has two right angles. So therefore, because FE comes from the center and it hits AC, then we say hypothetically that FEA is equal to 90 degrees. And then we go on by Euclid Book 3, proposition number 3, we also go on to say that FEB right here, is also equal to 90 degrees. Now, as you can see, FEA is inside of angle FEB. Now, if FEA is inside of FEB, then obviously this angle right here is going to be smaller than this angle right here. Well, these two angles can't be equal, but yet we just said that if FEA is 90 degrees and FEB is 90 degrees, then they're equal. And they're not. So therefore, if two lines are drawn like this, BD and AE, and they cut each other, they don't bisect each other. And that's what Euclid was trying to prove. Alright, I will tell you more in a future video, so stay tuned.